this is rates of chemical change review sheet. You can use this to revise, copy up your knowledge if you've missed a lesson. Really good way to start your revision. So the first question we're going to look at, list the ways we can measure rate. So what ways can we measure a rate of reaction taking place, or what kind of things can we see happening? Changing weight, changing colour, collection of gas being given off. So they're the ways that we measure rate, easy ways to get us started and know how a rate of reaction's taking place. So then before a rate of reaction to take place, you need to know a couple of things. First one, what do particles need to react? That is activation energy. They need to collide with enough energy. If they do not collide with enough energy, particles are always colliding, it's just they need to collide with enough energy for a reaction to take place. Then there are numerous ways that we can speed up a rate of reaction. So increase the temperature, increase the concentration, increase the surface area. You can also add a catalyst. These all speed up the rate of reaction. Sometimes they use the word enzyme instead of catalyst. Describe an enzyme. That is a biological catalyst. So a catalyst that's used in biology, normally in biological systems. Now, looking in a little bit more detail at how each of these things speeds up the rate of reaction. The first one is increasing the temperature. Particles will have more energy to move if you increase the temperature. They are more likely to collide with enough energy to react. Like I said before, particles are always colliding, bumping into each other, but when you speed them up, add more energy, they're more likely to collide with enough energy for that reaction to occur. Changing the concentration, a little bit different. There are more particles in the same area or volume, so there's more particles in the same space. More particles means more chance of collisions, which leads to more chance of successful collisions. As you can see here, this is a low concentration, this is a high concentration. So this is low, this is high. The higher concentration is the same space. The space hasn't changed. It's just that there's more particles. These particles, because there's more of them, they're more likely to collide. They're more likely to react, which leads to a quicker or higher rate of reaction. Surface area then is a bit different from the other two. Increasing the surface area means more space for the particles to collide, which means more successful collisions. So this is, say you've got a tablet, it's just one single tablet, really small surface area. There's only certain places on the outside for which the particles can collide. So it's only these bits here where the particles can collide. Now, if you increase the surface area, so it's still a tablet, but you've broken it down, maybe made it into a powder, there's a much larger place for it to collide. There's much more places for it to collide. If you just look at this diagram here, you've essentially increased the area for it to collide by over 200%. So you've increased that area where it can collide by over 200%. The final thing you can do to increase the rate of reaction is to add a catalyst. Now, catalysts work a little bit differently. Catalysts lower the activation energy. So like I said before, particles are always colliding, but unless they collide with enough energy, they aren't going to cause a reaction. So it lowers that energy needed for a reaction to occur, the minimum amount of energy needed to react. Now, catalysts are not used up. They speed up the rate of reaction, but you can use a catalyst over and over again.